Welcome back, video 19B, going to continue on with the student T distribution. So the shape of the model of student T's distribution is bell-shaped, just like the normal model. But the difference compared to the standard normal model, compared to Z, is that there's more area in the tails. Imagine taking Z and sort of tugging on those tails and spreading it out a bit more. It turns out that the larger your sample size, though, the closer that student T's model will be to the standard normal model. And in fact, when our sample sizes exceed about 100, there's very little difference between T and Z. So the larger your sample size, the closer these two become. Oops, what sample size? And next, we're going to illustrate what happens as the sample size changes. With the standard normal model, there's a single standard normal model, but it turns out for students T, there's an infinite number of different student T distributions. So for very small sample sizes, the student T's model will have a lot more area in the tails, much more area in the tails. The student T is a family of models. There's one for each sample size, and so officially we name these by what's called degrees of freedom. Which we'll often abbreviate with just the letters DF. But it's based on sample size. Degrees of freedom is going to be our sample size minus 1. So for any possible sample that you might have, a sample size of 10, the degrees of freedom would be 9. There would be one T distribution. If we had a sample size of 30, the degrees of freedom would be 29. We'd have a different T distribution. All of them are bell-shaped. It's just a matter of how much area is out in those tails. So let's look at some of these. So you have this in your notes. Observe the difference between the standard normal model and student T for varying degrees of freedom. You'll notice the degrees of freedom are down here. The standard normal model is the top model. It's on the board here. It's this red one. This is Z. And then this other one here where you have more area out in the tails, this is the student T model. And for this one, since the degrees of freedom is 2, that must mean that the sample size was 3. Degrees of freedom is always your sample size minus 1. So since the degrees of freedom is 2, our sample size for this one was 3. And you can see that there's a big difference. There's a big difference in the amount of area here that's out in this tail under this T distribution than the area that's under the standard normal distribution. And remember what Gossett said. He said especially for small sample sizes, he was having some issues here. He's testing beer. It would seem very appropriate when you're testing beer to perhaps have smaller sample sizes, like testing 3 beers. Much beyond that, I'm out. So it would seem that this would definitely be a case where he could have run into difficulty, and we see that there is a fairly significant difference there in the area in the tails compared to these two distributions. There's also more area in the middle here when you look under the standard normal model than when you look at the T distribution. All right, let's see how this changes. We're going to sort of drag this over here and see what happens as we increase our sample size. How does the standard normal model compare with students T? We said that as the sample size gets larger, that these two distributions are going to get closer to each other. So let's illustrate that with a couple more. So again, the standard normal model is the one on the top. On the board here, it's the red one. Student T is the one below this. And now I look on the second example, the degrees of freedom is 8. And so for this one, this must be for a sample of 9, since the degrees of freedom is 8. And you'll notice here, still somewhat of a difference, but the difference is nowhere as much as it was before. There's still more area under the tail for this distribution here that's on the top, out in the tail, the T distribution, than there is for Z. but not as much as there was for that very small sample size of 3. All right, let's crank up the sample size a little bit. Now there's hardly even, it's difficult to tell there's even 2 models here. The degrees of freedom now is 35. So here's what the 2 models look like when we have a sample size of 30.